What's up, folks? This is Mr. Smith coming from the garage wearing my Salty Crew hat, and I'm here to talk about your Google form that you guys filled out. So I want to go over some of that stuff and just some normal updates. Anyways, start of a new week, and on our Google Classrooms, I posted the week. This is your goal for the end of the week. Finish all your coding for your program. So by the end of this week, all your programming should be done. It should be 5 to 7 hours of your programming. So hopefully you've already finished 4, so you got 2 to 3 more hours. Again, you can do more, but that's kind of like the recommended. You should be completing prompt 2B. Then you're going to record your video of the program running. I'll be posting a video tomorrow with that on how to do that. Pretty easy. You're just going to, in Code Studio, there's this little button you can click on the top and it will just show your program. And then you can use, I would just use Screencast-O-Matic, and you can just put a little box around that and just record, no audio required. You don't need to talk or anything like that. Very easy. And it has to be, I think, 60 seconds or less. And then prompt 2A you should write. So that's kind of like the things you need to do for the project. Then there's a mandatory Google form at the end of this week again. Okay, so yeah, boom, that's what you're doing for the week. It will take some time to do that stuff, so try and situate it out. I did post on here how I would recommend breaking that down on your to-do list. So I would recommend maybe on the first day today and the next couple days finishing that program. Then I would say probably by the 22nd, so that's Wednesday, start doing your 2B prompt, writing it out. Again, do all your prompt writing in a Google Doc, and then we'll transfer it to its final resting place later. So in a Google Doc, 2B, write that out probably Wednesday. Thursday, make your video, and then Friday, do your response 2A, write up, which is basically talking about what's happening in the video. That's why you can't do 2A until after you've created your video. And then there will be another Google form check-in on Friday that you'll fill out. So really not that much. The 2 prompts are not that big. So the big thing is recording the video and finishing your code. Okay? So that's that. Let's get into your check-ins. So first of all, I had very few people respond, which means grades are going down. So thank you for those people who responded. Have you coded at least 40 hours? Do you have a good algorithm? Let's see if you have a good algorithm. I'm going to read some of them. Okay? So I'm not going to read all of them. Don't have one yet. Okay, my algorithm is about what happens when the fish is clicked in my game, and how it affects the coin score and lives of the player. Again, as long as it's a function, it's good. Okay, so I see a lot of clicker game. Here's one. I have a parent function called update score. That's good. With a parameter which determines how much a score will increase. Not only does this function update all of the text on the screen to match the variable amounts, it also updates the score to increase by the parameter increase. Good. It also calls 2 more functions. That is really important. Level up and check if in game. The function level up checks to see if the score is large enough to progress to the next level. If it is, then it updates the image and the text on the screen to the appropriate level of growth. The function check if in game checks to see if the plant has reached maximum growth, which is when it reaches 250 points. If it has, the function sets. Okay, what I want to take away from his algorithm, okay, is use of parameters is good. He has a parent function, so he's created his own function, and within that he has separate ones. So he can use that also as an abstraction as well, because abstraction needs those other ones. Okay, he didn't talk about having a mathematical or logical concept to it, but he says checking to see if it has a score, which is probably going to be our logical and mathematical component. So those are what you want in them. Okay, let's read the next one. Random number S with mathematical and logical concepts when choosing, which is going to be rock, paper, or scissors. So it looks like a rock, paper, scissors game. Also a parent function I've included when I play, call it back within it. Okay, I do like that we have a random number generator with a mathematical concept. Nice, rock, paper, scissors game, that's fun. I haven't gotten Tyler into finishing, okay. I'm coding a way to order a smoothie. when you pick a size, what flavor, the program will give you a price on the next screen. After this, I'm hoping to code a way to add tip. Okay, alright. Now, yeah, make sure you do a math function. My algorithm is within my function of balls 1 through 3. Each has an if statement checking the account, and every time it runs, adds 1 to the strike count or 1 to the ball count, depending on which function it is. I'm assuming you're making maybe like a baseball game. That's cool. Let's see. The computer will go through each index and sort the numbers. It will have a Boolean expression. Okay, Boolean expressions are good because they do include that mathematical operator. But that's not the only thing you need. You have to make sure it's within your function. My code does not yet have a solid one. Program takes user input from the user pressing key to move an image around. Okay, be careful of this one. Just because it's taking input, that's usually an on event, but that's not going to be a good program. So you want to make sure you have a good program. That might not be one. I have got my whole project code besides the score, so I'm planning to use the score code as my mathematical part. Okay, it's good as long as we know that we need that mathematical logical statement. Again, go back to your the video on algorithm to help you with that. Explain your abstraction. Okay, let's see, I got a good one here. To make it appear like the image with rotating commands, the user hide element and show abstraction. Looking for. Okay, my abstraction is a function called right answer. I have multiple pages for my project. Each page has a quiz with a button that has the correct answer. The function right answer has a parameter for the correct answer for each page. So they're using it multiple times. Smart. Inside the function, it says that even the correct answer is clicked. It will eventually add 10 points to the score. It manages complexity because each quiz page function has a function with a parameter correct answer. Great. Love it. Right now I'm having a little trouble with abstraction because I just have an on event. I'm going to eventually adjust this and score. Yeah, usually the score, if you're making some sort of game, the score update is where you can create good abstraction. Alright, have you identified an opportunity or difficulty? This is for your response to be. These can be anything. It's like, oh, here's an opportunity for me to save time. For example, that one student said that they created a function called right answer. By creating that function, that was an opportunity for them to cut down on the complexity of their code because they knew in each question it had to have that. So that's an opportunity right there. A difficulty, let's see, my difficulty was trying to figure out how to create 2 different games that connect to one. For example, there are 2 teams when playing a penalty shootout in 2 whole different scenarios. However, after watching some videos, I am finally understanding the concept and abstraction. Okay, so again, that's the great thing. If you don't know what's going on, an opportunity difficulty within the programming, that's what we're looking for. This is a great opportunity for you guys. You just talk about it. You talk about the struggle that you had, right? I had this difficulty or I had this opportunity. Let's see, here's this one looks good. It's long. For my complex to-do list, I hid the to-do text box and checkbox after the first row, and I used the show hide elements. That was a little too long. I don't want to get too into it. I had a very hard time finding out what I did wrong in one piece of code, and turned out I accidentally capitalized one of my functions. Okay, that seems like a really ooh, why would I even write about that? That's actually a difficulty. Okay, a difficulty, and you're realizing that when we're programming, it is so important to be very particular. And so that's great. You can talk about that. Okay. So this guy's or girl says, so far it's been relatively straightforward. That's fine, but you still need to talk about an opportunity within your coding where you can make something better or figure something out, or a difficulty you were presented and you overcame that. So the reason why they're doing it is because this create performance task is focusing on your ability to find some sort of difficulty and see how you overcome it and talk about that. Okay? Alright, any questions? This is my favorite part. Do you have any questions? Does it have to be a game, or can it be something else? I don't know why it doesn't let me read the rest of this, but it doesn't have to be a game. It can be something different. But the reason why games are usually well received is because there's a score function. So, but it doesn't have to be a game. I saw some person said they were going to show you how to order a smoothie, and it would update the price. Depending upon if you add certain things. So that'd be more than fine. You don't have to make a game. I would make something where they do something, it does update or change something. That would help you write an abstraction, write an algorithm that can contain abstraction and use mathematical and logical operators. See, I don't know why I can't read these, but most people said they didn't have any questions. So when boxing the algorithm with one, so I'm assuming like where you're going to box this, we're going to hold off on that. Don't worry too much about that, the boxing and stuff like that. I went over an algorithm video, but I'll probably make another video where I'm going to show how to actually post that code. Again, it's April 20th. This is due May 26th to the AP board, and to me, I'll probably have it due a week before. So if you guys are looking for a hard date, a week before that, I want everything in and done. So we still have over a month to work on this, and once this week's over, we should have the video, we should have the program, and then we can work on the nitty-gritty of getting that box around the algorithm. But you really want to focus on getting a good algorithm and abstraction right now. That's kind of been my focus. These were more questions. Due date, I'm going with a week before May 26th, so that's going to be May 19th, if that's a Friday. About then is when I want it. Is a clicker game a good enough project idea, or does it have to be more complex to get a good score? No, it doesn't have to be more complex. Don't do just a basic clicker game, because it will be hard to meet the qualifications for your algorithm and your abstraction. So you might want to make it a little bit more complex than just a straightforward clicker game. So, yeah. The hardest part is really coming up with a good project. I think I'm just going to go like this for the rest of the video. Yeah, that's the hardest part. Okay, email me. Google Hangouts. I'm doing them 2 or 3 times a week. Please join, ask questions. No one ever comes. No one ever shows up. No one ever asks questions. I have no idea if you guys are even alive. So please, I mean, I watched to see how many people watched the video last time and how many people responded. I have 12 kids respond out of 30 kids. That's not good. Okay? 15 kids responded out of the other class that has almost 38. So we need to maybe do more work. So you're going to see on your grade book. Boom.